this lesson, we'll be forming equations using the diagram that I have drawn. So let's say the equation for this cubic function is in this form of h of x is given by ax cubed plus bx squared. Now they tell you to find the value of a and b. So you know that to find the turning points is denoted or are denoted by O and B. You need to derive the equation of the cubic function and then equate it to 0, because the turning point is where the slope is 0. So the line will passing horizontally perpendicular to the x-axis. So that is not just that important. So let's check what can we do. The first thing that you can do, you know that you have to derive this thing, leading you to have 3 multiplied by ax to the 3 minus 1 plus 2 multiplied by bx to the 2 minus 1, and then this can be simplified to 3ax squared plus 2bx. Now you can equate this to 0 as it determines the the gradient on the turning point, which it is exactly 0. So substitute the value of x that you like. So I would advise you not to substitute this value here. We know it's a turning point, but it is insignificant because all the values are 0. So we can say 3 multiplied by a multiplied by 4 square plus 2b multiplied by 4 equals to 0. Now what can we do? We find we make a variable the subject of the formula. For me, I like b to make it the subject of the formula, so it's gonna be 2 multiplied by 4 is 8, b equals to negative. We take this to the other side to become negative 3. A multiplied by this thing will be 16. Now we make b the subject of the formula, so it's gonna be negative 6. So remember, when you divide this by 8, it's gonna be 2 multiplied by 3 is 6, and then multiplied by that negative, it's gonna be negative 6 a over here. Now let's call this equation 1. So what can we make equation 2? Equation 2, we use the original equation, so we substitute everything as a given coordinate. So we know this coordinates over here on our function. So let's say a multiplied by 4 cubed plus b multiplied by 4 square will give us 2. Now let's substitute this value on the value on b. A multiplied by this thing is like 4 multiplied by 4 multiplied by 4, which is gonna be 16 multiplied by 4. 4 multiplied by 10 is gonna be 40 plus 6 multiplied by 4 is gonna be 24. Yeah, it's 24, and then we are going to have 64 as the answer. So we're gonna say 64 plus this part is gonna give you, we will substitute this negative 6a multiplied by 16 equals to 32. Now let's deal with this part over here. Remember here I didn't write well, it's cubed. So it's gonna be A multiplied by 64 plus, I meant minus 6 multiplied by 16 is the same as 6 multiplied by 10 plus 6. This is gonna give you 60 and this gonna give you 36, and the answer is gonna give you 96. So it's gonna be negative, because we see this negative 96. A is equals to 32. Now let's deal with the like terms. It's gonna be, this part will give you 32, negative 32a equals to 32, and then the value of a equals to -1. Now to find the value of b, you're going to substitute everything on the equation 1. So let me change the pen firstly. B is going to be given by -6 multiplied by -1, and the b value is gonna be +6. Now let's rewrite this equation as our a is -1, so it's gonna be negative x cubed plus the b is 6 multiplied by x squared, just like that. Let's get rid of things that we won't need. Now let's do the question of finding the equation of a tangent touching the certain point on the function. So let's say it's over here, and that thing, it's like this. My drawings is bad, so I'm not gonna draw anything. So let's find a equation of a tangent passing through that point. So how can we, let's think of any coordinates that can fit on this part. So I can say it's 5 and maybe 25. This will not fit well. Let's deal with this, the stationary point, not the stationary point. Let's deal with the midpoint between the two turning points, which can be given by 2 and maybe 16. Now you are told to find the equation of the turning point. I mean the equation of the tangent passing through that point. Firstly, you need to find the gradient of the line by using this equation. So for the gradient of the line, we are firstly required to derive this thing, as I said. So the derivative of h of x, or the h prime of x, is going to be equals to -3x squared plus 12x Now let's substitute the value of x in this case to find the gradient. So it's gonna be -3, the x is 2, it's gonna be square over there, 12 multiplied by 2. This part is gonna be, I think it's gonna be 4 multiplied by -3, which will give you -12 plus 24, and then this thing is gonna give you 12. As you can see, the gradient is positive. The line will go just like that, so that is not really important. Now, as we know the gradient, the other thing to do is to use this equation that says y minus y1 equals to the gradient multiplied by x minus xy. Y minus our y in this case is 16 equals to the gradient is 12 multiplied by the x minus the x value is 2, and then the value of y is gonna be given by 12x minus 24 plus 16, which we will say 12x minus, so it's gonna be 8 over there, -8. So this will be the equation that we were looking for. Now let's do the other question, which is to find the value of a, or the coordinate. To find the coordinates of a, you know only one thing. You know that the x in this case is 0. I mean the y, it is 0, as it is lying on the x-axis, is the x-intercept. So we are going to say x -x cubed plus 6x squared equals to 0, and then let's factor out x, or -x I may say, and then this thing's gonna be x squared minus 6x, which will be equals to 0. The first x that we know it is equals to 0. For this part, you're going to still factorize, which will also lead you to get 0, or you may take nothing to the other side, just factorize to get x minus 6 equals to 0. So this is the same as this one, it all equals to 0, and then the other x equals to 6. So it means the coordinate is gonna be 6 and 0 over here. So let's say the other x says you must find the x values for which our function increases. As you can see, in order for you to see the function is increasing or decreasing, check it from the left hand side to the right hand side. So as we are going from here maybe, or from there, we can see when we go, it is decreasing, starting to increase when we reach 0 as the x value. As we reach 0, start to increase, and then when we reach another turning point, having the x value of 4, it start to decrease. So what does this mean? It means our function increases where x is less than 4 and then it's greater than 0. Just like that. That will be your answer. Now listen to the interesting question. It says find the value of x where the function concaves up. Let me say it down instead. So for the function which is concaving up, it means the second derivative is greater than 0. And for one that concaves down, it means the function or its second derivative is less than 0. So let's look at the one when it concaves down instead. We are going to derivate this thing twice. So the first derivative, you know it, we did it saying that it is equals to negative x squared plus 12x. Now for the second derivative, we can say this thing equals to negative 16 x, negative 6 x plus 12. Now for the interesting part, we say negative 6x plus 12 will be, because we are talking about concave down, will be less than 0. Now let's find the value of x where it concaves down. Negative 6x is gonna be equals to, it's gonna be less than negative 12. Finding the value of x, we'll find out that x would be less than 2. This will be your answer.